Hello everyone, my name is Alvaro, and in this video I will be solving another problem from the blind Leetcode 75 problem list. Today I will be doing problem 53, which is called maximum subarray. So let's get to it. So the problem statement says, given an integer array nums, find the contiguous subarray containing at least one number, which has the largest sum, and return its sum. A subarray is a contiguous part of an array. So what it means by contiguous is simply like, imagine that you grab a chunk of the array. It's simply that all of these are together and there are no gaps. So if we grabbed -3, 4, and -1, and then a 1 and a -5, that would not be contiguous because there will be a gap here, which is a 2. So in example 1, the output is simply this, because this is the largest one. So all of this adds up to 6. And there's no other subarray that adds up to more than that. In example 2, this would be the output, pretty straightforward. And in this one right here, it's the sum of all of them. So let's get to it. So pretty much, right, in this problem, well, I guess if you want to work on this problem by yourself, now would be the time to pause the video, because it's when I'm going to explain how to do it. So the main idea here, right, is that we keep track of what the largest sum overall has been so far at any point in the problem, and then what is the current sum that we're dealing with. The largest sum is pretty easy, right? It'll simply be the largest current sum that we found at any point. So whenever current sum is greater than largest sum, then simply we update largest sum with current sum. Now the challenging part of this problem is understanding when and how we're going to modify current sum. And that's what we're going to discuss now. So let's look at example 1, because I think example 1 illustrates pretty well what we want to do. So imagine, right, that after we have traversed this part of the problem, we have a -2, okay? That would be the current sum. And then we are at 1 after that. So if we observe, right, if we add up these two numbers together, -2 and a 1, that yields a -1. Now, we have to agree that whatever number we encounter afterwards, right? So whatever number we encounter afterwards, if we add it to a 1, the resulting sum will always be greater than adding that same number to a -1, because 1 is greater than -1, right? So we're going to use this principle to update current sum. The idea is that whenever the number that we encounter is greater than the sum between the current sum and the number itself, so whenever num is greater than that, the current number, then simply the current sum will now be the num itself. So in this case, because 1 is greater than -2 plus 1, we will update current sum to equal 1. And after that, we compare whether current sum is greater than largest sum, and if it is, then we set largest sum equal to the current sum. And that'll be how we update current sum throughout this entire problem. And this will allow us to solve the problem in one pass. So let's start to code it. So the first thing is that we're going to initialize our variables, and we're going to start with them at -infinity. Oh, I meant to put sum, not num. And the reason why we do this is because the default will be a -infinity, and at any point, whatever number we encounter in the subarray, it will always be greater than this. So the returning value will always be a number in the array. Because if, for example, if we set largest sum equal to 0, right, and the array consists of only negative numbers, then the output will always return 0, because no matter what, the negative number will always be smaller than 0. So that's why we set these equal to float equals -infinity. So for num in nums, if num is greater than num plus current sum, then we set current, oh, okay, I called it like this, cool. Current sum equals num. The other case will simply be handled by adding num to current sum. And now the last thing that we need to do is check whether current sum is larger than largest sum, since we have already updated current sum. And then at the end, we return largest sum. And this should work. I've tested this solution before, and eventually it beats 89% of submissions. So obviously as usual, the times are a little bit inconsistent, but there you go. So yeah, let's discuss the runtime and the space complexity of this problem. So the runtime is big O of n because we traverse through each element in the array exactly once. And the space-time complexity is big O of 1 because we're simply storing variables. And that'll be the end of it. So yeah, I hope you enjoyed this video. Make sure to hit a like and subscribe and all that. And thank you very much for watching it. See you in the next one. Bye-bye.